Good morning, ladies and gentlemen, and welcome back to this course on conditioning program designing. This is lecture 4 of week 1, and I will be taking you through the topic improving the efficiency of the anaerobic system. I am Colonel Dr. Anup Krishnan, and it's a privilege to be associated with this course. I will be covering the topic as per the following outline: definition, introduction and review, determinants and limiting factors, adaptations to anaerobic training, training principles, training methods, some practical applications, and as always, we will end with a take-home message. The learning objectives of this lecture are to define the anaerobic system and their physiological roles, describe the limiting factors to anaerobic performance, identify effective training strategies for improving efficiency, and to apply the principles of monitoring and program design. Now, let's talk about the anaerobic energy pathways. There are two main anaerobic pathways: the ATP-PCR or Phosphagen system and the anaerobic glycolysis. What they do is they produce ATP without the presence of oxygen or without direct reliance on oxygen. And this system is more dominant in high intensity, short duration efforts less than 2 minutes. The Phosphagen system produces ATP for up to 6 to 10 seconds, and the anaerobic glycolysis system produces ATP up to 2 minutes. Right? Now with this understanding, we know that this system is critical for sprints, jumps, wrestling, football, and similar sporting activities. The ATP-PCR system supplies the immediate energy 0 to 10 seconds. There is also a concept called stored ATP, which gives energy for up to 3 seconds. After that, it is the ATP-PCR system, and then the glycolytic system takes over up to 2 minutes. The system works by phosphocreatine breakdown. No oxygen is required, and it is useful for high intensity, short duration sports such as sprinting and weightlifting. The glycolytic system works by breaking down glucose, produces lactic acid, useful for moderate intensity events such as boxing and 400-meter running. Let's talk about the efficiency of the anaerobic system. Efficiency means more work done per unit substrate and less accumulation of fatigue metabolites for given power. Basically, per unit of ATP, more work is done, and at the accumulation of level of the metabolites, fatigue metabolites such as lactate, or at lactate threshold, the body is adapted and is able to do more work at the particular given lactate threshold. This improves repeated sprint ability, power output, and recovery between high intensity efforts. Efficiency also helps in sustaining high power repeatedly. Not only for maximal effort, but for maintaining quality. And this is the key for intermittent sports and combat. So anaerobic system is very important in sustaining high power repeatedly, maintaining quality of high intensity movements, and this is why it is very important in intermittent sports and combat. There are some physiological determinants of anaerobic power. Number one is muscle fiber type. We know that type 2B and type 2X fibers are increased with anaerobic training. Enzyme activity, creatine kinase, phosphofructokinase, and lactate dehydrogenase increases with anaerobic training. The buffering capacity of due to carnosine and bicarbonate improves due to anaerobic training. Neuromuscular coordination improves with anaerobic training. And cardiovascular support and PCR resynthesis between the efforts will improve with anaerobic training. As we know, if PCR is resynthesized, ATP production will increase. There are some limiting factors. If PCR is depleted rapidly, hydrogen ion accumulation increases, causing acidosis. Phosphate and ADP buildup, neural fatigue, and impaired calcium handling. These are the limiting factors for the anaerobic production of ATP. So, how do you improve? What are the key adaptations with training? With anaerobic training, there is an increase in the glycolytic enzymes, increase in the PCR resynthesis, increase in the buffering capacity, improvement in neuromuscular efficiency by motor unit recruitment, and there are structural changes which occur in the fast twitch muscle fibers. Let's talk about some of the techniques. HIIT. Repeated bouts near or above VO2 max. What is the principle? These short all-out intervals stress glycolysis. And you can target the adaptation by manipulating the work-rest ratio. What I mean to say is, you can improve aerobic also, you can improve anaerobic also, and somewhere in between also with your targeted adaptations, and if you vary the HIIT techniques. It is effective for anaerobic improvements when the bouts are short and maximal, for example, boxing, kickboxing, etc. Sprint interval training. This elicits large glycolytic stress and strong anaerobic adaptations by increasing the glycolytic enzyme activity and improving the buffering capacity of the blood. Okay. How do you do it? 4 to 8 30-second all-out sprints, jumps, whatever, with 3 to 4 minute rest. This improves the glycolytic enzymes and lactate tolerance. There is a dual benefit of anaerobic and aerobic. Short maximal bouts for improving the ATP-PCR or phosphagen system. 6 to 12, 5 to 10 second sprints with full recovery. This targets the phosphagen system and it primarily trains the phosphagen system and the neuromuscular power. Improves peak power, rate of force development, and neuromuscular efficiency. Let's talk about moderate duration training. 20 to 60 second efforts at 90 to 100% HR max or VO2 max. Targets the glycolytic capacity, for example, 8 into 40 second uphill runs. or bouts of 15 to 60 seconds at very high intensity. This will stress the glycolytic system strongly, and it is useful to target anaerobic capacity and tolerance to hydrogen ion accumulation or acidosis. But because you are doing it at high acidotic levels and high anaerobic capacity levels, recovery has to be managed. If you just give these training bouts, make sure you give a long recovery period before the next training bout. Strength and power training. Heavy resistance, more than 85 to 95% of one random maximum. You may use explosive lifts or plyometrics. Heavy resistance of 1 to 5 Rm and ballistic plyometric training increase motor unit recruitment, RFD, and muscle cross-sectional area, thereby improving anaerobic power production. Now, it has to be combined with sprint power work for transfer. Fine. You give strength training, you give power training, but make sure high intensity workout or heavy resistance workouts are given only to trained athletes. Otherwise, there is an increased injury risk. So be careful and be clear on when you will start this component of training to which athlete. Neuromuscular conditioning and technique. So this will improve with sprint mechanics, acceleration technique, jump techniques, and will reduce wasted work and increase the mechanical efficiency. Now this is critical for, fine, you're developing the motor qualities, but you have to translate that improved motor quality to performance. So that is why this neuromuscular conditioning and technique training is important. You may use techniques such as sprint drills or resisted runs. And this type of training will combine physiology and biomechanics. Because you're going to improve the buffering capacity, you need to give good quality nutritional support. If you want to enhance the buffering capacity, you have to increase something called beta-alanine and carnosine. Now, beta-alanine is available only from animal sources of protein, such as fish, meat, eggs, milk, etc. So, vegetarian athletes, there is a problem. You have to focus on supplementation. By vegetarian athletes, I mean pure vegetarian or vegan athletes. Indian vegetarian athletes take milk and milk products, so they are getting some beta-alanine from their animal sources. Creatine supplementation is important to raise muscle PCR, which will improve the PCR availability. For glycolysis, you have to increase the carbohydrate and hydration. Because the body is in a state of high glycolytic flux, high carbohydrate and hydration is important to sustain this state. We must consider the dose, timing, and athlete testing. Recovery strategies. We have to have active recovery strategies which improves PCR resynthesis and improves lactic clearance. Active recovery strategies such as long slow runs, massage. There are so many other active recovery strategies. So you must be using them intelligently. You may use passive recovery for better PCR resynthesis. Passive recovery such as sleep, music, relaxation, etc. Optimize the recovery duration as per your work rest ratio and optimize the methods active versus passive for desired adaptation. Basically, clarify what adaptation you want and play with the active or passive recovery and work and rest ratio intelligently to get the desired adaptation. This is what I mean. Sleep, nutrition, cold water, compression support are adjuncts to recovery. How do you monitor these adaptations? You monitor these adaptations by lab tests such as the Wingate cycle test or field tests such as repeated sprintability, shuttles, time sprints. You can also use questionnaires such as RPE and wellness questionnaires, and all these methods are useful to adjust the load and progression. Wingate or RSA testing. Wingate cycle testing, it is a maximal cycle ergometer test which measures peak power, mean power and fatigue index, and it is useful for lab and field correlation. This is supposed to be the gold standard for jumping sports. RSA tests mimic sports demands and track repeatability because it is done on the field. And both these tests have direct relevance to sports performance. Work rest ratio. Now, if you are going to improve PCR, work rest ratio of 1:6 to 1:12. That means 6-second sprint, 60-second rest. If you want to improve the glycolytic system, 1:3 to 1:5. 30-second sprint, 90-second rest. If you want to improve aerobic, 1:1 or continuous. If you want to improve phosphagen, very high intensity, 1:6, 1:12 work rest. That means 6-second work, 36 to 72 second rest. For glycolytic focus, 1:3, 1:5, 30-second work, 90 to 150 second rest. Use measured velocities and powers to enforce intensity. That means use standard measurements to enforce the intensity. This is a sample 8-week mesocycle for improving anaerobic conditioning. Week 1 to 2 focus on technique and strength foundation. Week 3 to 5 SIT plus overload. Week 6, because you are giving overload, deload. Week 7 to 8 competition preparation, repeated sprint work. For example, 2 anaerobic power sessions, short sprints plus strength training. 1 anaerobic capacity session, SIT or 30 to 60 second interval sprints. 2 supportive sessions, technique, mobility, low intensity aerobic for improving the recovery. You cannot keep giving one particular type of exercise. Okay, you have to vary and change the type of exercise, the intensity and the recovery for gaining whatever motor quality gains you want. And during the deload week, gradual progression in volume and intensity. I hope this is clear. Some amount of it is clear, so that this is a general guideline or general sample 8-week mesocycle which I have given. There are a lot of other aspects which go into it, which will be covered by the other faculty in the subsequent lectures. Sample training sessions for improving ATP-PCR, 10 into 6 second maximal sprint, 60 second passive strength, rest. Sample training sessions for improving ATP-PCR, 10 into 6 second maximal sprints with 60 second passive rest, and strength training 3 reps of 4 squats at 85% of 1 RM. If you are focusing on glycolytic session, 8 into 30-second all out on bike, 4-minute active recovery. Always include proper warm-up, activation and cool down sessions during any training sessions. Periodization. Align the anaerobic emphasis with the season phase. For example, in the pre-season, build power and capacity. In the competition phase, maintain quality, reduce the volume. In the off-season, develop strength and power. In the transition phase, focus on recovery and aerobic base. More importantly, consider something called positional demands. More important in team sports, where, for example, in football, there is a goalkeeper, there is a forward, there is a defender. This is what is called a positional demand. Please make sure you do not give the same training program for all of them. Training program should be individualized based upon the position the player is playing and also depending upon the fatigue responses of the individual. Individualization. So how will you individualize the training program? You can individualize the training program based on something called fiber type interference testing. This is an invasive test. It is not recommended, generally not recommended. You can do indirect tests to determine what is the fiber type, sprint power and RSA. Athletes with high type 2X fibers may need more repeat sprint tolerance work. Others may need power to weight improvements. Make sure you do proper testing and then give a personalized training design. For sprinters, you have to focus on PCR and neural drive. For midfielders, you have to focus on repeat sprint endurance. For combat athlete, focus on glycolytic tolerance and always consider injury history and recovery capacity. These are some of the practical considerations while giving a training program. Ensure progressive overload. Goes without saying. Focus on adequate recovery. Monitor the recovery using HRV, wellness, sleep, heart rate, resting heart rate, etc. When you are doing maximal sprints and heavy loads, under technical supervision. Monitor for overreaching. Manage the hydration, nutrition and warm up to reduce the injury risk. And important to manage anaerobic, aerobic development because very few sports are completely anaerobic, very few sports are purely aerobic. So there is always a combination of the two, and depending on what type of sport, place or the position the individual is playing, you may need to tweak the training program accordingly. What does the research and evidence summary say? So strong evidence support HIIT, SIT and strength power training for improving anaerobic performance. Areas needing further work are the dose which is required for different sports, the long-term effects of chronic SIT and individual responder profiles have to be mapped and charted out. The problem with individual responder profiles is most of the tests which we need to do to map this are invasive and it is generally not allowed. Key takeaways. Targeted short all-out work improves phosphagen and glycolytic systems. The work-rest ratios are the key for targeting the particular systems. Training has to be paired with strength, power training, and nutritional support like creatine, beta-alanine for the best results. Monitor using field tests, Wingate, RSA. Tailor the program to the athlete and the sport. And periodization plus individualization equals to success. These are my references, ladies and gentlemen. Kindly go through them in the interest of better understanding of the topic. I seem to have finished, ladies and gentlemen. This brings us to the end of lecture 4 of week 1. Thank you for patient listening. Thank you and Jai Hind.